movie, we go through this old exam question to remind ourselves about organic reactions. You should download from the link below and try this yourself before resuming the movie. You might need to brush up on your knowledge about organic reactions. Click on that link to help you to do so. Okay, let's first make sense of what's going on here. We see that compound A reacts with a base. Potassium hydroxide is a base, and in the other case, we're not told what the base is, but it's also a base. So it reacts with a base, but it reacts with a base in two different ways, depending, clearly, on some other conditions that are present. And in one of these ways, that produces this substance here, which we recognize as being an alkene. How do we recognize that? Because of this double bond. And in the other of the two ways, it produces an alcohol. So we first need to ask ourselves, well, what substance can react with a base to either produce an alkene or an alcohol? And the answer is, it's a haloalkane. We see that the alkene reacts by hydration to produce compound B, which we're told is the major product. So we need to understand, how do we determine what would be the major and what would be the minor product in this particular reaction? Let's go across to the other side, and we see that this alcohol, it's a primary alcohol, so we need to understand, what does that mean? This alcohol reacts with what we recognize is a carboxylic acid, to be more specific, ethanoic acid, which is what's found in vinegar. And so we're getting a carboxylic acid reacting with an alcohol, and we know that that is esterification, so an ester is produced. Click that link to remind yourself about esterification. So as we've already discussed, compound A has to be a haloalkane. So I've written a structural formula for a haloalkane, that X stands for any halide. And when a haloalkane reacts with a concentrated base, like potassium hydroxide, we get an elimination reaction. What happens is the potassium ion bonds with a halide, removing it. And the hydroxide ion bonds with one of the hydrogen atoms, removing it. And once those two are removed, they're replaced by a double bond, forming an alkene, because each carbon still has to have 4 bonds. We can see that that is elimination because we've only had things taken out. We're told that this alkene then undergoes hydration. It reacts with water, and that is an addition reaction. What happens is that double bond is opened up, and the hydrogen and hydroxide, which together make the water, fill in the spaces where that opens up. Now, there are 2 possible products. The hydrogen could come in there and the hydroxide there, or the other way round. And one of those will be the minor product and the other the major product. So let's draw both of them, and then we figure out which will be the minor, which will be the major. So notice how the hydrogen has come in over there, and the hydroxide from the water has gone in there. Now let's make the other product, which has exactly the same, except those are switched around. Now, how do we decide which of these is the minor and which is the major product? We make use of the rule, the rich get richer. What does that refer to? It refers to the number of hydrogen atoms that the carbons have. So let's go to the alkene before the hydration reaction. And we look at the 2 carbons that are involved here. Which one is richer in hydrogen? This one, it has 2. That one only has 1. So the richer one gets richer, meaning the richer one is the one which must get another hydrogen in the major product. Which is that? It's the first one here. So that will be the major product, and this will be the minor, meaning both of them will be produced, but this one in a greater abundance than that one. We can see this is an addition reaction because water is added into the compound with nothing else coming out. Now if we come to this side of our flow diagram, we see again that there's a base being added to compound A. It's not actually specified in the question that it is potassium hydroxide, but let's for simplicity just say that it is. So again we have a base added, but this time, instead of us getting an elimination reaction forming an alkene, we get a substitution reaction forming an alcohol. Why the difference? Because this time we use a dilute base. What is the difference between a concentrated and a dilute base? They are both strong bases, so it's got nothing to do with the strength of the base. In other words, nothing to do with the degree of ionization of that compound, but rather it's got to do with whether the base is diluted in water so that it's a solution, that's a dilute base, or whether it's neat, it's concentrated, it's a liquid. And depending upon that, we either get that elimination reaction forming the alkene or the substitution reaction forming the alcohol. We're told that here we get a primary alcohol formed. So that has to be the alcohol. How do we see that it's a primary alcohol? Because the hydroxide group is connected to a carbon, which is only connected to one carbon. That's why this is a primary alcohol. And that's why I knew that when I created this compound, when I wrote that structural formula, that I had to put the halide at the end, because only then would it have undergone this reaction to form a primary alcohol. If that halide had rather been in the middle, then you see that the substitution would have resulted in the hydroxide coming in that space, and that would have been a secondary alcohol. So this primary alcohol was formed by this reaction. We need to speak a bit more about why this reaction is a substitution reaction. We can see that that potassium is going to take away that halide. In fact, here it did the same, and we didn't draw that in, so let's just add that in. In both cases, we get a salt, potassium halide. If this halide, for example, is a chloride ion, it would be potassium chloride. So that happens in both cases. In this case here, where we get the substitution, in addition to that, we also get the hydroxide coming into the compound. That's why substitution. This has actually been swapped for that. So we can see that this one goes away with the potassium, and the hydroxide that had been with the potassium now enters into compound A, and so turns compound A into an alcohol. Whereas if we come back here, we see that the potassium took away that halide, and the hydroxide took away a hydrogen, so that we got water coming out. So we can see this one is purely elimination. Only things are being taken out, nothing is being added in. And that's why we get the formation of that double bond to replace the things that have come out. Whereas here, we're getting substitution. Something's coming out and something's going in. Now we have this alcohol reacting with this carboxylic acid. We've already said that the name of this carboxylic acid is ethanoic acid. We can see the two carbons, that's why it's ethanoic acid. And that is esterification. What happens during esterification? This H from the alcohol bonds with this OH from the carboxylic acid to form water, which is removed. Because of that, we need a dehydrating agent as a catalyst. We use concentrated sulfuric acid. Remember that liquid sign means concentrated, not dilute, it's neat. Concentrated sulfuric acid is the catalyst in esterification. Then these two parts join to form an ester. The ester is made up of two parts. One part came from the alcohol and the other from the carboxylic acid. And the names also reflect those origins. This part here came from propan-1-ol, and it's called propyl. This part here came from ethanoic acid, and it's called ethanoate. Obviously, at the end of all this, one needs to make sure that you do answer the questions that you are asked. We asked the types of reactions for this reaction, and this reaction. Let's just also do this reaction, so let's fill those in. We've already discussed it, but this one here is an elimination reaction. This here is an addition reaction. This is a substitution reaction. And this here is esterification. We're asked for the conditions under which this occurs. We've already discussed the fact that the base needs to be diluted, but we also need to apply mild heat. Let's anyway also discuss the conditions of this one, even though we're not asked. We need a concentrated base, and we also need heat, and the base needs to be placed in ethanol. We also asked about the catalysts used over here, and I've already mentioned that, sulfuric acid, concentrated sulfuric acid. We're asked about the IUPAC name of this primary alcohol. We've already said it's propan-1-ol. We're not asked for the other IUPAC names. We worked this one out anyway. But in the comments below, why don't you give me the IUPAC name of this major product? We're asked to give the structural formula. Here it is. And that's the end of this question. Don't forget to like and to subscribe, and also leave me a comment below.